Hello everyone, welcome to Life Studies. In this video, we are going to solve a list of 10 SQL interview questions that you should solve before your data analyst or data engineer interviews. And you can see here, these are the 10 problems starting from 10 to 20 as part of roundup series. I hope you already solved 1 to 9 problems in this roundup series. And if you observe, these are the problems that we already solved in data engineer or data analyst SQL interview question series, right? So now we are going to solve all in a single video. So now you can see here, these are the problems like now, starting from 10, return employee details whose salary is higher or lower than the average of all employee salary. So, we need to return those employees details whose salaries are higher or lower. These are the two problems. So, interviews will be asking either higher or lower. I'm just combining as a single problem. Now, we need to compare all those salaries with the average of all employee salaries who work in that particular organization, right? So, this is how, we are going to use here a subquery. So with help of that subquery, we can easily solve this problem, right? So next problem, return employees details whose salary is higher or lower than their department's average salary. So here, it is also similar to the 10th question, but you need to understand here, we should not consider the all employees average salary. We should consider their department's average salary, and we need to compare their employees salaries with their department's average salary, and then we need to return those salaries are higher or lower than that particular employee salaries. Okay, so this is how we are going to solve this problem. Like, we need to return department wise average salaries, and then we are going to combine actual table with department's table. Whatever we derived department wise average salary, so that we'll be getting department wise average salaries, right? And this is one way that we can do it. Otherwise, we can also use here window function. With help of window function, we can easily solve this problem, right? So now with help of window function, we can easily retrieve department wise average salaries, and we can easily retrieve whatever the data we want. Okay, so next problem, that is question number 12. Return employees details whose salary is higher or lower than employee who joined just after or before the current employee, right? So how we can solve this problem? So either in the given table they have to mention joining dates, or they have to mention employee IDs. So with the help of either of them, we can easily understand that this particular person is joined before to particular person or after to particular person, right? So with the help of them, we can easily solve this problem, right? But you need to understand, we can use here window function. Those are lead and lag, right? So in order to find previous responses, we'll be finding lag. In order to find the next responses, we'll be finding lead. So that is how we'll be finding who joined next, who joined before, and then we are going to compare with the current employee salaries, and we can return whatever the data we want. Okay, next question 30. Return employees details whose salary is higher or lower than their manager's salary. So this is also very important and most frequently asked interview question. So it will be giving employees details with their respective managers also, and we need to return both. Here you need to understand, it is given only a single table having all employees details with their respective manager details, but you need to understand these managers also employs to those particular organization, right? So those employee IDs are nothing but employee managers only, but you need to understand for employee ID 1, employee ID 5 will be the manager. So that is how the indication will be mentioned manager IDs. So with the help of self join, we are going to retrieving manager salary. Okay, so that we can compare with current employee salaries with the manager salaries. Okay, so then we can easily retrieve whatever the data we want. Next problem, that is 14th one. Return the second or third highest earning employee details. So in order to find the nth highest or nth lowest earning employee details, we can easily solve this type of problems with help of window functions, right? So you can see in the second question, return the second or third lowest earning employee details. Okay, so next problem, that is 16th one. Return the second highest or lowest earning employee details in each department. So this 14 and 15 is entire organization wide we are finding. The next one, 16th problem, is for particular departments. For each department, we need to find the second highest or second or even lowest also we can find, right? With the help of window function. In case of window function, we can use here, in order to find each department wise, we'll be using partition by, right? So that is how we are going to solve this 16th problem. Next one, 17th one. Return the top 3 or top 2 highest earning employee details. So this is also similar to the second or third, but in case of second or third, we'll be finding exact one. But in case of top 2 or top 3, we'll be using less than or equal to. So that we'll be getting all those employees details by using window functions, right? So here we'll be using either ranks or dense rank. But when it comes to top n details, always prefer to use dense rank, because we don't know how many people are having the same salaries, right? So that's why we will be using window function dense rank to solve this problem. That is 17th one. Next one, return the top 2. So wherever you find top n, so always prefer to use dense rank. Okay, so return the top 2 highest or lowest earning employee details in each department. So this is entire organization wide. This is for each department wise we are going to find. Okay, so similar to these problems only, but we are going to use here less than or equal to. So here only equal to will be using, but here less than or equal to, so that all employees who comes under that particular rank will be come into picture. Okay, so that is how we will be using window function, that is dense rank. We will be solving this problem. Next one, return younger or older age employees details in each department. So in order to find younger or older age employees in each department, what we have to know? We should know the age of each and every employee. So without knowing age, we cannot do it, right? So there will be age column will be there in a given table. Now for each department, so here with the help of window function, if you use partition by of department, so that you'll be getting each department wise details. For each department wise, what you have to do? You have to rankings the rankings on the, you have to give the rankings on the basis of their employee ages. So here the two questions, younger one and older one. So as per the age is ascending order, so that it will be assigning age in ascending order from 1 to, I mean, on the basis of lower to upper, right? So that is how we'll be using order by age to define in which one you are trying to find, right? So that is how we are going to assign rankings on the basis of ages in ascending order or descending order as per your requirement, and then we are going to return whatever the data we want. Okay, so next one, 20th last question, return the manager details under whom the highest number of employees work. So there are managers also given, right, in our given table. Now we need to find manager wise number of people are working under him, and then we need to return only the highest one. So highest number of employees who work under that particular manager. Then so we need to return that particular manager details. Okay, so we can solve this problem with help of is group by, right? So with help of group by and count of number of employees for each department, sorry, each manager. Okay, so with help of group by we can easily solve this 20th problem. Okay, I hope you understood how we are going to solve these 10 problems. Now let's see how we are going to solve these problems in SSMS. You can see here I just considered a sample data set having different columns like employee ID, name, department, salary, age, and manager IDs. And these are the 10 problems that we are going to solve. We'll solve one by one. Okay, so now we start with 10th problem. So return employee details whose salary is higher or lower than the average of all employee salaries. Okay, so how we can solve this problem? So we need to return those employees details whose salaries are higher or lower than the entire employees, like all employees average salary. First, you have to find average of all employee salary from employees details, right? Now if you observe, this is going to return a value that is the average of all employee salary. So now what we have to do? We have to compare this value, this salary like average salary with all employee salaries. Then we have to return those employees details whose salaries are higher or lower than this particular salary. So how we can do that? With help of simple subquery, right? So we are going to use select star from employees, employee details, where salary is greater than or less than, right? So first we'll solve greater than, so that we'll be getting all employees details whose salaries are higher than the average of all employees details, all employees salaries, right? So now if you know the average salary, you can easily mention here. So for example, if I mention here 50,000, okay, that's going to return all employees details whose salaries are greater than 50,000. Now in place of 50,000, what we have to return? We have to return average of all employees salary. So that's how we are going to use this as a subquery. So now in place of a static value, we are going to mention this value, so that how it's going to return? It's going to taking for each and every record while it is filtering. This is the where class, right? So that's how we are filtering the data. So with help of this where class, this is the condition, salary is greater than, this is the average salary, right? So now if I execute this one, that's going to return those employees details whose salaries are higher than the average of all employee salaries. So similarly, if we use less than, that's going to return remaining employee salaries, right? So those details, those employees details whose salaries are less than the average of all employee salary. But if you are using like this, what's going to happen? It's going to happen like, it's going to filter the data row by row. So for each and every row, it's going to execute each and every time. So how many times this is going to, executing? This is going to executing how many times? For the all employees, right? So how many records are there in this employees table? Those many times this is going to execute, right? But if you are doing like that, it's going to taking more time, right? Because each and every time you have to go to this table again, you have to find the average of this salary. So rather doing that, you can easily solve with help of with CTEs, right? So with help of CTEs, you can easily store this value as the CTE, so that you can use it later on, later point of time, right? So now with CTE as same thing, I'm just using average of salary from employee details Okay, so now if you use select start from CTE, that's going to return the same value. You can see now. You can see what is this where no column name was specified. So while you are using CTEs, while you are using extraction of any other column, this is the average value, right? This is not a direct column. So you have to mention column name, average salary. Okay. So now if I execute this one, you can see here the same value, right? But what is the difference between this one and this one? So we are storing actual this average value as a city. Rather finding for each and every record, you have to find. So it has to do like it has to go and check the find. I mean, it has to find the average value again and again for each and every record. But here, you're storing as a value. So it need not to go again and finding average values, right? So that's how we are using like this. But now what we are doing, selecting all data from employee details where salary is greater than what? So that is average salary. So because we stored this one, right? Now if I execute this one, you can see here. So why it is returning invalid column average salary? So here, let's see, I'm going to mention select average. You could not mention direct one. So you are taking it from CT, right? Select average salary from CT. Okay. So this is how you have to mention. Now you can see you are getting all employees details whose salaries are higher than the average of all employees salary. But what is the difference between this one and this one? Here you are already storing the value as a city. Rather finding for each and every record you have to find here, right? So that's how we are just increasing the speed of the SQL query. This is one way of optimizing with the help of CT, right? I hope you understood. So similarly, you can also find it like using less than. So if you use less than, that's going to return those employees details whose salaries are less than the average of all employees salary. You can see now. Okay, so this is how we'll solve this 10th problem. Okay, next one, that is 11th one, return employees details whose salaries are higher or lower than their department's average salary. So now we just found like those employees details whose salaries are higher or lower than the entire organization average salary, right? But now we have to compare with the department's average salary. So how we can solve this problem? So with the help of Windows function, we can easily solve this problem, right? So let's see that. Select star all. I'm going to return all data. With addition to that, what I'm going to return? I'm going to return average of salary from employees details. So now if you observe, this is just an aggregate function. Now if we add overclass, then what's going to happen? If you add overclass to any aggregate function, that aggregate function will start working as window function now. So how many windows? In overclass we didn't mention anything, so that how many records are there in this entire employees table, those many records come under a single window. For the entire single window, this value will be allocated. Now if I execute this one, you can see here, this is the exact average value of all employee salary, right? So that's why for each and every record present in this table will be allocated. Now what we have to return? We have to return the department wise average salary. So that is why you should mention here partition by department. So if you use partition by department, that's going to divide how many windows. So you define window. So this partition by will help us to define number of windows. How many windows? Number of distinct departments. How many departments are there? Those many number of windows will form, and for each window the average value will be allocated. Okay, in which window how many records are there? Those many records, this value will be allocated for all those records. Now we can see here, for engineering department, this is the average salary. For finance, this is the average salary. For HR, this is the only one. So that's why you're getting only this one. For IT, you're getting the average of this. I mean, the average of these two is the same value. All right. So marketing, the average. You can see now. So this is how we can extract average of department salaries by using partition by and in window function. Right. So now we can easily retrieve those employees details whose salaries are higher or lower than their department's average salary. So if you observe, this is the employee salary in engineering. So what is the engineering department average salary? The sum of these two divided by 2, right? This is the one, right? So now if we compare this one and this column, we can easily retrieve whatever the data we want, okay? For this entire column, I'm going to mention as department wise average salary. So now if I execute this one, you can see now. So these are the employee details, okay? We are just returning, right? We are just returning all employee details with addition to their department wise average salaries, right? So now what we have to do? We have to compare with their salaries with this department wise average salary. Okay, how we can do that? By writing one outer query. Select whatever the data you want, you can mention them from this entire table. For this inner query, I'm going to mention alias like anything, okay, where H dot salary is greater than H dot department wise average salary, right? So now if I execute this one, that's going to return those employee details whose salaries are higher than the average of their department's average salary. I mean, the average of their departments only, right? So we are not considering the entire organization. We are considering only but those particular wherever the employee is working in that particular departments only we are considering, right? So that is how you can see here we are just comparing with their particular department's average salary. Okay. Similarly, you can use less than. So now if I execute this one, you can see remaining 6 employees we are getting it, right? So there might be equal to also will be there. So that's why you can see now. Okay, let's try with only equal. So there might be only one employee will be having only one employee is there, HR is there, right? So that is why this is the average department salary is equals to salary. All right. So that is why you can see now. So you can use any response. These are the responses like those employee details whose salaries are less than the average of the department's salaries, right? Okay, I hope you understood this problem. Now let's see how we are going to solve 12th problem. Return employee details whose salary is higher or lower than employees who join after or before to them. So now what we have to return? Let's see the table first. So if you observe, we need to return those employee details whose salaries are higher or lower than the employee who joined after or before to him. First, we'll consider higher for these two responses and then lower for these two responses. Okay. So now, in order to find those employee details whose salaries are higher than the employee who joined after to him or before to him. Okay. So in order to return those responses, first you should return this is the current employee. Who joined after, who joined before, you need to return them. Okay. Let's do that. For that, I'm just using window function. In window function, lead and lag we are going to use now. So now, if I use lead over lag over from given table. Okay. Now, if I execute this one, you'll be getting error. What are the errors? It will be expecting like order by in war class. While you are finding lead and lag any ranking function, you should mention order by, right? You can see the error now. You can see here what is the error. First expecting error is lead function should be having 1 to 3 arguments. Okay. So now what you are trying to find? You are trying to find who joined after, who joined next. I mean, right, likewise. So in order to find that, so what do you want to find? Like employee name, who joined after, who joined before, right? So that is how you're going to return on the basis of return employee details whose salaries are higher or lower than the average. Sorry, not this one. 12th one, right? Return employees details whose salaries is higher or lower than the employee who joined after or before him. So these are the current employee salaries, and we need to return those employees' salaries who joined after or before, right? So now what you have to do? You have to use salary. So salary of next employee. Okay, next employee who joined. Now similarly, you can use lag of salary in the sense you are trying to find salaries of those employees who joined before to him. Okay, these are the two columns. So how we can define who joined before or who joined after? In order class, in over class, we have to mention order by. Order by what? So if we mention employee ID, that's going to return salaries of lead employees. So in this order, we are trying to find. So in this order, for the first one, who is lead? That is next one. That is 2. Right? By default, this lead will take it as a single value, right? Single next. So only next value. So that's why you'll be getting next employee salary. So here, if we mention same order by employee ID, that's going to return previous employees details, right? Order by employee ID. If you observe, we are just mentioning in ascending order so that you are going in this order, and for each and every value you are finding the lag of salaries. So for at this position you are finding the lag value, that is 3, who joined before, right? So now if I execute this one, you can see now what are these two columns? These are the next employee and these are the previous employee salary. So now if you observe, who joined first? Employee ID 1, that is Venkatesh, whose salary is this one. Who joined after? That is 2, Harsha, whose salary is this one. So now if you observe, this is the exact salary, right? For Harsha, who joined after Ganesh? Ganesh salary is 75,000. You can see here. So all these are next the employee salary. So now if you observe last value, what is this last value? There is no other employee joined after this Fahad, right? So he is the only one who joined last to this organization. So that is why we will be getting null, because there is no other employee. Similarly, these all are previous employee details. For Venkatesh, there is no previous employee. So that's why we are getting null. For Harsha, who is previous? That is employee ID 1, because this is a 2. Employee ID 1 is the previous employee. So Venkatesh salary, how much? This is the 1. So that's why you are getting here. So even if you observe last one also, for Fahad, who joined before to Fahad? Bosch. both salary is 69,750. You can see here. So that is how you need to understand. With the help of lead and lag, we are finding all previous and next value. Okay, I'm going to change this column as next employee salary. Okay, this as previous employee salary. Previous employee in the sense who joined just previous to the current employee. Okay, now you can see we'll be getting. Now what is our question? Return those employee details whose salaries are higher than the employee who joined after or before to him. So now if I return any question, I mean they are going to ask you different question. Only after also they are going to mention. Only before also they are going to mention. You can use any of them whatever you require. Okay. So now I'm just considering selecting all data from this one. I'm going to mention alias with H, where H dot salary is greater than H dot only next employee salary. Okay. So now if I execute this one, you can see here you are returning those employee details. Even if you want to have any details like only up to this one, you can mention only them. You need not to return these then. I'm just mentioning star. So that's why it is returning both, right? So now these are the employee details whose salaries are higher than the employee who joined next to them. So for Ganesh, who joined fourth employee, and fourth employee's salary is this one, 35,000. You can see now. So fourth employee salary is, okay, let's see that also here. Fourth employee salary is 35,000. So that is why you are getting third employee details. You can see fourth employee 35,000, right? So he's the one who joined next to the Ganesh, and Ganesh salary is 75,000, and we are returning those employee details whose salaries are higher than the employee who joined next to him, right? You can see now. You're just considering all those details of employees whose salaries are higher than the employee who joined next employee salary, right? You can see now. For the fifth one, there is a sixth one. Next employee joined is sixth one, and sixth salary is 40,000, 40,500, and this is higher, right? So that is how we are returning all employees details whose salaries are higher than the employee who joined next to them. I mean the salary of the employee who joined next to the current employee. Okay, so even if you just mention less than, that's going to return those employee details whose salaries are lower than the employee who joined next to them, right? For one, so you can see here, okay, one employee is returning, and why is second is returning here? Once the salary is 29,000, and this is less than the second employee, and second employee salary is this one, so that's why it is returning one. Second employee this one, and you can see here there is no third, because of this is the employee whose salary is less than the third employee salary, but the third employee salary you can see here that will be higher than the second employee. You can see this is 75,000, this is lower, right? So that is why we are getting only the second. You can see now, and third we are not getting because the next employee salary is lower, right? So this is how we are returning those employee details whose salaries are lower than the salary of the employees who joined next to them. Okay, now so these are the next employees we are trying to find. So similarly you can use here previous also. You can see now, so these are the details whose salaries are less than the employee salary who joined previous to them, right? For four, who joined previous third, so you have to compare with this Usha salary with the previous employee salary, and this is lower than the previous employee. The third employee salary will be higher than the fourth employee salary. You can see now this is higher than the fourth employee salary. So that is how you can easily find these particular responses. So even if you want to have greater than, you can mention that. Okay, so these are the details of employees whose salaries are higher than the employee who joined, than the salary of the employee who joined previous to the employee, this current employee. Okay, I hope you understood. So this is how we can easily solve this problem with help of lead and lag. And you need to understand in which order you are trying to find. Okay, in which order you are trying to find any responses you want. Okay, I hope you understood. So next problem, written employees details whose salary is higher or lower than their manager's salary. So here we found like higher and lower for both previous and next, right? So now this is different question. Another question, written employees details. I'm just mentioning this table now first. You can see now this is the given table. Now we need to return those employee details whose salary is higher or lower than their manager's salary. So here it is given employee details like ID, name, department, salary, age, and manager IDs. So you need to understand all these are employee IDs, all these are manager IDs. But what is the context? All managers are also employees to that particular organization, right? So now if you observe, these are also employees only, and so that's why we are considering these manager IDs also employees ID only. Okay, because all managers also employees to that particular organization, but all employees won't be a manager. All employees won't be a manager, but all managers will be employees. So you need to compare this value equal to this one, not this equal to this one. So it will be like you might be confusing, like if A equal to B, then B equal to A, right? You might be thinking like this. No, it's not correct context wise. So all employees won't be a managers, but all managers will be an employee. So that's why we'll be using manager IDs equals to employee IDs, not employee ID equal to manager. Okay. So now let's see. So how we can do that? So if you retrieve this 5 employee, who is 5? This employee, right? So you need to have, these are the salaries of employees, and these now if I return like 5th employee salaries here, next one. So this is the manager salary. So 66,000 is a manager salary. You have to get that salary here, and 29,000 this salary is the Venkatesh salary. So for employee ID 1, employee ID 5 is a manager. So you need to return here one more data, I mean few more data as per this particular response, right? So how we can do that? So we have given only a single table, and you need to return these particular responses. How could you do that? These managers IDs equals to this employee ID. So if you use join, like self join on the basis of these particular columns, like employee manager ID equal to employee ID, then those particular manager details will be joined, right? Wherever 5 is there, these 5 entire record will be joined, right? So 2, this 2 entire record will be joined. So for 2 is the only manager. So this 2 will be coming here. Okay. So next one, likewise, this is going to returning, I mean joining the same table, right? So that's why we are calling it as self join. Okay. Let's see how we can do that. Now select, I'm just considering A dot star from employee table, employee details. I'm just considering A join. So because we are going to use the same table twice, so that's why I'm just mentioning with different aliases. Even if you are using a single table, you are mentioning with the different aliases. Join in the same table, but this time I'm going to mention B. Okay. Now even if you want to return all columns, let's see how we can B dot star. Okay. On which condition you have to mention that. So on which condition? Assume this is one table. Alright, same replication another table will be there. So you have to use in first table, that is manager ID has to be equal to, in second table employee ID, right? So now first table A dot manager ID is equals to, in second table, that is B dot employee ID, so that you will be getting all these respective details like as one more table, right? So now you can see how it's going to return. It's going to return like these particular, because we have used these two columns. So that's why if you observe, these two column values will be same, right? And we return those respective details for this particular, right? For employee ID 1, 5 employee is a manager, and this is the 5 is the employee ID, and we are returning all 5 details here, right? So second employee, for second employee, second is the manager, so that's why we are getting same here. For third is the fifth one, and we are getting fifth details here. So likewise, if you observe for 10th, third is the there, third is the manager, third is manager in the sense third employee is 3, you can see here employee 3 details. Likewise, if you observe, these all are manager details, these are first table are employee details, right? So now if you observe, this is not employee name, this is a manager name, you can change this as manager name. This is a department, no problem. This is not a salary, this is a manager salary, that is from second table. So now we are trying to return those employee details whose salaries are higher or lower than their manager salary, right? So this is the manager salary. If you observe, fifth one, for employee ID 1, fifth is the manager, and fifth salary is this, which one? 66,000. You can see here 66,000. So this is the employee salary, that is one salary, and Venkatesh salary is this one. This is the manager salary. So for Harsha, his salary is 52,000, this one, but his manager is who's same, so that's why you'll be getting the same, right? Ganesh salary is 75,000, whose manager is fifth one, right? Fifth salary is 66,000. So that's how this salary is manager salary, that is from second table, right? That is B table. So now we will be using only this column only, because we are trying to return those employee details whose salaries are higher or lower than their manager salary, right? So we have to compare with only this particular column. So that is reason I'm just returning only that particular column, salary as manager salary. Okay. Now if I execute this one, that's going to return only all employee details and their respective manager salaries we are returning, right? If you observe fifth one, 66,000, wherever fifth is there, fifth salary is won't change, right? Because fifth is the only one employee, and his salary only returning, and he is the manager for different employees. You can see now, right? So now if I use filter this data with this particular salary is greater than this manager salary, what are the details we'll be getting? We will be getting those employee details whose salaries are higher than the manager salaries only, right? So now if you write, or you can also use CTE also. You can also CTE, just try to use that with CTE as Okay, so now select star from CTE. That's going to return the same data, right? You can see now same data. Now where we are going to use salary. This salary is nothing but employee salary. And if we use manager salary, that's going to return manager salary. So we are returning those employee details whose salaries are higher than their manager salary. You can see now. You'll be getting all those employees details. Even if you want to return any particular data, you can mention all of them. Okay, in rather returning all star, if you are returning star, that's going to return all data. So that's why you're getting manager salary also. So even if you want to return any particular data, you can mention only them. Okay, so now if you observe, these salaries are higher than their manager salary only. These are their respective manager salary only, right? So if you observe, each and every value will be higher, right? So this is how we can solve this problem with the help of self-join. These are the details of employees whose salaries are higher than their manager's salary, right? So even if you use less than, that's going to return those employee details whose salaries are lower than their manager's salary. Okay, I hope you understood. So next one, 14th one, return the second or third highest ending employee details. So here, given question is asking for return second or third highest ending employee details. So how we can solve this problem? So we can solve this problem with help of window function easily, right? By using ranking function, right? So you need to understand, we don't know how many people are having the same salary or not. But when it comes to second or third, you need to understand here, if in case people are having the same salary, how it's going to return in rank contains rank. In case of rank, if there is a matching or there, for example, let's do that. Let's write it and you'll understand now. Rank over from employee details. Okay, so now if I execute this one, it's going to return error. Why? Because of you're trying to assign a rank. On which basis? You have to define it, right? You have to define the order. You can see here the order. So you have to mention in which order you are trying to mention. First, we are trying to find the second or third highest. Highest in a sense, we need to mention the rankings on the basis of salary in descending order, right? So that the highest one will come in the top. Now, if I mention like this, order by salary descending order, that's going to assigning rankings from top to bottom. Now you can see here the highest one will be this one and the second highest this one. Since there are all distinct values only, so that's why you are getting all distinct, right? So now if in case if you have common values like 75,000, 75,000, those will be indicated as 1. Okay, for the next one, the second will be indicated as 3 if you are using rank, right? Because rank will skip a sequence of numbers when we have number of matchings are there. So that is where if you're using rank, that's going to skipping, right? So let's see here, if you have 75,000, 75,000, you'll be getting 1 and 1. For the next one, you'll be getting not 2, that's a 3, right? So that is how you should use here dense rank. Okay, so now if you use dense rank, no matter of any number of matches are there, for example 75,000, 75,000 is there, so that rank will be allocated 1 1. For the next rank will be allocated 2 only. In case of dense rank, dense rank won't skip any sequence of numbers. It will be giving a sequence of numbers even any number of matches are there. In case of rank is going to skip how many matches are there, those many it's going to skip for the next one. Okay, so now if you observe, we assigned rankings on the basis of salary for the entire organization. So what is our question? We need to return second or third highest ending employee details. So with the help of this particular column, I'm going to mention this as DR and K. You can see now. So now if I use select data, whatever the data you want, you can mention that. From this one, I'm going to alias giving the alias A, where A dot DR and K equal to 2. That's going to return second highest only, right? Second highest ending employee details. This is the second highest salary, and these are the second highest ending employee details, right? So if I mention 3, that's going to return third highest ending employee details. You can see here, this is the third highest, right? So this is how we can easily solve this problem with help of ranking function, especially use dense rank, because we don't know how many people are having the same salary. So for example, if we observe 1000, 1000 and 800 and 700. Okay, if you have salaries of employees like this, so this, if you use rank, the value will be allocated 1. For this one, it also allocated 1 because the same salary, right? For the next one, it won't allocate 2, it will allocate 3. Okay, so next one, it will allocate 4 if you are using rank. So if you are using rank, shall we use second highest? No, right? Because it's missing, right? Here it's missing. So if you can use rank when you are finding the top one, right? Top one in the sense highest one. But when it comes to the second, third, you should use range rank because it's missing right here, right? So that is the reason you always prefer to use range rank. Okay. So in case of range rank, you can see 1. This is also will be allocated 1. For the next one, it will be allocated 2. Okay. Next one, this will be allocated 3. So this is a sequence of numbers. But in case of rank, it will be skipping. How many skipping? So this is one matching. So one rank will be skipped off. Okay. That is how you should use, always prefer to use range rank. Okay. Next one, 15th problem. Return the second or third lowest ending employee details. This is also same problem, but in case of here, we are assigning ranks on the basis of salary descending order. So highest to lowest we assign. So same thing, I'm just copying this one. Now, in place of descending order, I'm just removing this one. So that how it's going to returning, it's going to assigning the rankings on the basis of lower to highest one. You can see now, the lowest one will be allocated rank. And the next one, you can see rank 2, right? So if I use 3, that's going to return third lowest. This is the third lowest. So if I use 2, that's going to return second lowest ending employee details. You can see now. If I use 1, that's going to return the lowest ending employee details. Lowest one is this one. Okay. So this is how we can easily solve this type of problems with the help of window function. Okay, returning second or third lowest ending employee. You need to understand in this order. So you are finding the lowest one, you have to mention order by salary in ascending order, so that the lowest to highest will be rankings will be assigned. Okay. Now you can see here, next problem, 16th problem, return the second highest or lowest ending employee details in each department. So now I'm just copying this same one again. Now if you observe, we need to return second highest or lowest ending employee details in each department. So these are the responses, like we assigned rankings for the entire organization. So why it is returning incorrect syntax near employee details? Okay, let's see here. I'm just executing alone. You can see now. So we just assigned rankings on the basis of their salary from descending order, right? So now this is asking us to find, okay, second highest or lowest. We can find both. Okay, second highest we'll find, and then we'll find second lowest also. So now if you observe, we need to find that for each department wise. So in order to find for each department, what we have to remember? We have to use to partition by of entire data on the basis of department. Now if I use partition by department, that's going to divide, that's going to allocating the rankings for each department wise in salary in descending order. So if you observe, in engineering we have 2 employees and those are allocated rankings for each department. This is the highest one, this is the second highest one. In finance, this is the highest one, this is the second highest one. In HR only 1, so that's why 1 HR, 1 IT, 2 employees are there, and you can see here 1 and 2, right? So for in case of marketing, you can see here highest one 1, second 2, third 3. So for each department, so you have to use partition by department, right? So now if I use where DRNK equal to 3, how it's going to return? It's going to return third highest ending employee details in each department. Who are third? Only this employee, right? Only we have marketing department, only we have 3 employees, right? So that's why we are getting only 1 employee. So now if I return 2, that's going to return second highest ending employee details in each department. If you observe, we have different departments are there. In each department, we are returning the second ending employee details only, second highest ending employee details only, right? So now if you use only 1, that's going to return highest ending employee details in each department. You can see now, in each department, these are the 1 in the sense for each department, we allocated ranks on the basis of their salaries, right? So now if I change this descending order to ascending order, that's going to return the lowest ending employee details in each department. So if you observe engineering, this is the highest one. So now we have only 2 employees in engineering department. The next one will be the by default lowest one. You can see now, this is the next one, that is the lowest ending employee details. In finance, HR is the only one. So even if you use like descending order, ascending order, you will be getting here one, HR is the only one. So you will be getting the same one only. In IT, you can see here, okay, lowest ending employee details for each and every one. Even if you want to find 2, that's going to return second lowest ending employee details. You can see here, we are not getting HR because in HR we have only 1 employee. Okay, I hope you understood. So it is all on the basis of, if you want to find the department wise, you have to use partition wise. If you want to find like higher, you have to use descending order. You have to use rankings allocating on the basis of descending order because you are trying to find the highest one, right? So if you are trying to find the lowest one, you have to mention ascending order. Okay, that's how the rankings will be allocated. And you need to understand, always prefer to use range rank because we don't know how many people are having the same salaries. Okay, I hope you understood. So now if you observe, this we are going to return, okay, 17 problem, return the top 3 or top 2 highest ending employee details. So here the same problem, but rather writing the second or third highest, we are writing the top 2, top 3. So when it is asking like top n, always prefer to use dense rank only. Okay, so I'm just copying the same one. You can see now. So how we can return them? So we are just assigning these ranks highest one. So top 2 or top 3 highest one. So what you have to do? You have to allocate these rankings on the basis of salary in descending order, right? So that it's going to allocating the salaries of employees from highest to lowest for each department. So this is for each department, but this question is not asking for each department, right? So you can remove this one, and the lower question written, okay, you can see here for each department this is the one, right? I'm just copying this one, I'm pasting it here. Okay, now I'm just removing here, removing this one. Okay, you can see now returning top 3 or top 2 highest ending employee details. So now if I remove that one, it's going to allocating the rankings on the basis of salaries for the entire organization. You can see now entire organization. So if I use 2, that's going to return the second highest only. If I use less than or equal to 2, that's going to return top 2 employees, like top 2 highest. You can see now top 2 highest earning employee details only. These are the 2 employees, right? So even if I ask top 2 descending order, I mean lowest top 2 descending, top 2 lowest earning employee details, how could you find? So you just mention in descending order, just mention ascending order, right? So here you can also change this to 3. Now if I execute this one, that's going to return top 3, right? Top 3 employees, I mean top 3 highest earning employee details. Okay, so now if I change this to ascending order, that's going to return the bottom 3, I mean top 3 lowest earning employee details. You can see now. So if I remove descending order to ascending order, that's going to return top 3 lowest earning employee details. You can see now these are the top 3, right? So if I use 2, that's going to return top 2 lowest earning employee details. You can see now only top 2. So if I use 3, that's going to return the next value for 29,700, right? Top 3, you can see now. So this is how we can easily solve this type of problems with the help of window function. In window function, we can use ranking function, especially dense rank. Okay. So now if you see here, return top 2 highest or lowest ending employees details for each department. So when it comes to each department, you have to use partition by. Same thing, same problem. So this is top 2, right? So now if you observe, I'm just using salary descending order so that we are returning top 2 highest ending employee details, right? You can see now. So why it is returning top 2, right? So here first we'll see only this one. So we are just assigning rankings on the basis of salary, right? On the basis of salary for each department. When it comes to each department, we have only 2 employees for the most of the departments. But if you observe, in marketing only we have 3 employees. So other than this one, we'll be getting top 2 means all you will be getting, right? So other than that particular employee in marketing, we have 3 employees and we are not getting that, right? So these are top 2 highest earning employee details in each department. Because we have only 2 employees of most of the departments, we are getting all of them. Okay. So similarly, if I use top 3, that's going to return all details because we have only 2 employees most of the department. You can see here, third highest earning employee details. Okay. Similarly, lowest, how could you do that? For each department, just remove descending order to ascending order. Now you can see anyway you'll be getting all details on it because we have only these are the few employees, right? So if I use 2, that's going to return lowest 2 earning employee details. You can see here it's returning lowest one. So actually if you use 3, that's going to return lowest 3. If you observe marketing 48, 52 and 58 is the highest one. So first lowest is this one, second lowest, third lowest, right? So if you use 2, that's going to return only these 2 responses, right? That is 48,000 and 52,000. It won't return this one, right? Because these are the top 2 lowest details. Okay. Now if I execute this one, it won't return third employee, that is 58,000. You can see now top 2 lowest earning for each department. So in order to find each department, you have to use partition by. So on which order highest, if you are finding the highest, you have to use descending order so that rankings will be allocated from highest to lowest. If you are finding the lowest one, you have to use ascending order, right? So this is how we can easily solve this problem with the help of window function, that is especially dense rank. You need to remember partition by and in which order you are trying to allocating the rankings. Okay. So next one, return youngest or older age employee details in each department. Okay. So now we have to return first one, consider youngest employees in each department. So when it comes to each department, you need to remember we have to use partition by. So let's see here, we are going to allocating the rankings on the basis of their ages now. not salary, because we are going to consider the ages, right? So on this particular column only we can decide that employee is younger or older, right? So now if you use select star comma, and then I'm just using, you can use rank or dense rank, no problem here, because all people will be having, okay, let's see, always prefer to use no problem dense rank over from employee details. Okay, so now if I execute, that's going to return error, because you have to mention in which order by age. So now if we define order by age, that's going to allocating the rankings on the basis of ages in ascending order, right? So this is for entire organization wide. So we allocated rankings on the basis of lowest age to highest age, right? So now what we have to do, we have to find it for each department. So you have to use partition by department. So now if I use partition by department, that's going to allocating the rankings for each department. So the lowest one will be allocated 1, the second lowest 2. Likewise, we have allocated rankings on the basis of ages in ascending order, right? So if you want to find the youngest one, what you have to do, you have to mention it ages in ascending order, so that the one will be indicated as lowest one, lowest age only, right? So in engineering, this is the lowest one, and engineering, this is the highest one, right? So now if I use where this column equal to 1, that's going to return the youngest employee details in each department only, right? So now if I return select star from this entire department, now I'm just giving here as drnk, okay, where a dot drnk equal to 1, that's going to return the lowest, youngest employee details in each department. You can see now in engineering, this is the youngest one, in finance 40 is the youngest one, in HR 54 is the youngest one, because he's the only one, and IT 31 is the youngest one. So if you observe, all returning the minimum ages, less ages, we are returning only youngest employee details, right? So if you use descending order here, that's going to allocating the rankings on the basis of their ages in descending order. Now if I return this one, that's going to return older age employee details in each department. You can see now in engineering 38, in finance 42, in HR he's the only one, IT 32, marketing 54. You can see now. So because 34 is the same, so that's why we are getting the same here, right? So this is how you can easily return youngest or oldest employees in each department as well. So if he is asking for entire organization, you just remove partition by, so that it's going to return entire organization wide older one, right? So because of we are using descending order, right? So this is the highest, highest age 54, and these are the details of those employees who are oldest one. So now if I remove this one, that's going to return youngest employee details. This is the one. Okay, I hope you understood. So next one, return the manager details under whom the highest number of employees work. Okay, so let's return the data. Select the star from employee details. This is very simple problem. This is a given problem. Now what we have to return? We have to return those employee, okay, return the manager details under whom the highest number of employees will work. So if you observe, under fifth, okay, fifth 3. So there are 3 employees are working under fifth manager. So 2, 2, 3, 4. So 4 employees working under this particular 2, right? So if you observe, 2 is also working under him only, because he is the only one, right? He himself is the manager. He is going to work as an employee, and he is going to work as a both, right? So now how we can do that? So we just use manager ID wise count of employee IDs, okay? And then what we have to do? We have to group by of manager, right? So that's going to return, okay, invalid column manager ID. Okay, let's see the data first. Okay, manager ID. Okay, spelling mistake here. Okay, now if I execute this one, you can see here we are getting this one, like 1, 2 employees are working, 2, 4 employees are working, 3, 2 employees. Likewise we have, right? So now what we have to return? We have to return the employee, the manager under him the highest number of employees working, right? So you have to use here, you can use city with city as this one. Okay, now I'm going to assigning rankings. Select star comma rank over, okay, I'm going to use here dense rank, no problem, dense rank over order by second column, right? This column. So on this particular column we are going to mention, right? So for that I'm just mentioning number of employees. So I'm just using this column, order by this one, descending order, right, from CTE. Now if I execute this one, that's going to allocating rankings on the basis of the number of employees. So 1 is the highest one. So even if you can use directly, right, like order by this column, descending order, and you can use top n, but we don't know the same, another manager also will be having same number of employees, right? So that's where always prefer to use this particular window function, ranking function. Okay, so now if you observe, manager 2 is the having highest one. So now if I use here, I'm going to use it here again, CTE2 as select star from CTE2 where dr and k, I'm going to give this as dr and k equal to 1, so that that's going to return highest, I mean highest number of employees who work under that particular manager. So what we have to return, we have to return those particular details. This manager ID is nothing but employee ID only, right? So now we have to return that also, right? So how we can do that? I'm going to mention this as CTE3 as this one. Now select star from employees. I'm going to mention A join CTE3 on which one? So manager ID is equals to, that is CTE3. I'm going to mention this as C on C dot manager ID equal to first employee, that is A dot employee ID only, right? Because this manager also employees only. So now if I execute this one, you can see here we are returning employee ID 2 and this is the manager, right? So now if you observe, whatever the columns you want, you can mention only them. So now if you observe, I'm just mentioning A dot star. You can see here, this is the manager, that is Pandey. Under him, the highest number of employees are working. Those are 4 number of employees are working. I hope you understood all of these problems starting from 10 to 20.